Hello students. This video is going to help you work through the matching functions activity for today. Our goal is to analyze characteristics of tables, graphs, and equations and do the matching. To start, we're going to look at what can a table quickly tell you about a function. If the x values are increasing, then the function itself would be increasing if the y values are going up. If the x values are increasing and the y values are going down, then the function would be decreasing. Don't forget about slope, linear equations, rise over run, change in y's over change in x's. For any function, you can always put x equals 0 into the function to determine the y-intercept. And domain, we can check the x values in the table. Range, we can check the y values. So let's give this a shot quick. We're going to try example number 1, match the table to the graph. And I'll show you a couple of things, but as soon as you know the answer, you move on and you don't have to check all of these. First thing I'm going to notice right here is look at the y values. Well, actually the x values are increasing. The x values are going up. And as the x values go up, the y values go down. So this function right now is a decreasing function. And if you look at our graph, as the x value goes up, in this graph, the y values are increasing. Same thing with these three graphs. The only possible answer, as the x values go up, the y values are decreasing. So I know right away that of the four graphs, this is the answer that matches with the table, just from that piece. Now, let's check a couple other things. What if I decided to check slope? Slope can be a good idea. I'm going to take my y2 minus y1 over x2 minus x1, and when I find the slope, I get negative 3 over 1, and a slope of negative 3 between these 2 points. But I can't be satisfied with just one pair of points. What if I check the next pair? And I do y2 minus y1 over x2 minus x1, and I end up with negative 5 over 1. Here you can clearly see the slopes are different, so this is not a linear function, which reduces out option right here as a potential candidate for this table. Now, the one thing that you should definitely look at is how do you compare domain and range? So remember, domain is your x values, and if I look at my table, my domain goes from 1 to 6. And on my graph, I want to make sure that the domain or the x values here for each piece contain all of those points from 1 to 6. And you can see this graph goes from negative 4 all the way up to 40. That definitely contains 1 through 6. Here I go from negative 3 to 18. That also contains 1 through 6. And down below, those graphs also contain 1 through 6. So domain doesn't really help us narrow down any choices, but what about the range? Well, the range is always your y values. And look at the y value. This has a highest y value of 39 and a low value of 4 in the table. So my range goes from 4 to 39. We always start with the lowest number. 4 to 39. Well, here's my y values in the table. This says that I go from negative 1 to 7. And that doesn't show all the y values. So I know for sure that this equation does not meet the needs of our table. Same thing here. I go from negative 2 to 32, and I need to be up to 39. So this one doesn't work as well. The last two, negative 4 to 40, negative 4 to 40, both of those conditions hold true. But we know that this is our answer right here because it is the only decreasing function. All right. So what about the next one? I'm going to quick erase. By the way, you can always rewind, pause this video if you need to go back and look at anything. So the next one, what about this function? Well, let's take a look at increasing, decreasing. As x increases, what's happening to the y values? Y is also going up. So increasing function, which eliminates this choice right away. could be one of these three. Now the next thing I'm going to look for is what's happening between the two outputs. Notice we are not going up by 1. We're going up by 2s, 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 and then 3s. We don't go up in this consistent pattern, so we have to be careful. And that's where you got to check more than a couple points here. If you're going to check slope, I got the output 10 minus 6 over 5 minus 3, and that is 4 over 2, which is 2. So I've got a slope of 2 between these 2 points. Well, notice, if I check the next 2 points, that 14 minus 10 is 4. 7 minus 5 is 2. I'm going to have the same slope here, and things are looking pretty good. And then I go 18 minus 4, 14 is 4. 9 minus 7 is 2. So pretty consistent, but we got to be careful. Now all of a sudden, 24 minus 18 over 12 minus 9 doesn't give me 4 over 2. It gives me 6 over 3, but reduced. There's my slope of 2. And if you check here, we've got difference of 6 over 3, which is 2. So that proves this is linear. The only possible answer for linear is right here. You could also compare the domain and range. Just really quick. Domain in the table goes from 3 to 15. I need to make sure that my x values contain 3 to 15. And look at the bottom one. We already know this isn't an option, but down here, that doesn't go to 3 to 15. So that's not an option either. And then look at your range. Range is the y values. My lowest y value in the table is 6. The highest y value is 30. And I want to go from 6 to 30. Notice my y value in this table only goes from -1 to 7. Here's -1, 7. Doesn't work. And the last one, -2 to 32, that meets our conditions that are needed. So more confirmation that that's the right choice. All right, what if we have an equation? What can that tell us about a function? Well, biggest thing, remember y equals mx plus b. You can easily identify the slope and the y-intercept. Quick little hint, y-intercept for any function is when you plug x equals 0 into the equation. All right, what about the linear function. This linear function is a straight line, consistent slope. As x's increase, the y's increase. This would be an increasing function. If it was going the other way, decreasing function would go down from left to right. A quadratic function can be a parabola. It's a U-shaped graph. If it's increasing or if it's positive a value, the graph's going to open upwards. If there's a negative in front, it's going to open downward. The square root function, you can definitely see a starting point, and it's going to slowly increase as you move from left to right. All of these functions can shift left and right depending on the behaviors of the equations, so be careful of that. Here we have the cube root function, which is kind of like an elongated s. This would be an increasing cube root function. And then we have exponential growth or decay. Exponential growth kind of starts off going really slow and then it increases very quickly. Exponential decay starts up high and it starts to decrease very quickly and then starts to slow down over time. All right, let's take a look at matching an equation to a graph. So really quick, you can see this is a friendly linear equation. If I start, I can always put a +0 at the end, and that's my y-intercept. But right away, there's my slope, y-intercept. So I'm looking for a y-intercept of 0 and a straight line, quick and easy. Y-intercept, and you can check the slope. Just be very careful with the tick marks and how it's set up with the domain. This one starts at -3 and goes to 18. So you'd have to kind of guess each, I shouldn't say guess, you should calculate. Each tick mark here looks to be 3. So -3, +3, 6, 9, 12, 15, 18. So you can check to see how the scale is set up by reading the domain and range. But we know very quickly that This equation right here is the only linear one, so there's my option. But double check the y-intercept and the slope when possible, squared. If I rewrite it because that tells me more information. It kind of gives me a really nice piece. X squared, definitely some type of parabolic. And notice it's a negative. That means the graph is going to be opening downward. But what would happen if I plug in x equals 0? If x is 0, my output is negative 40. There's my y-intercept. So I'm looking for a parabola that opens downward with a y-intercept. When x is 0, y is 40. So notice right here, this is the only function that's open downward of our four choices. Over 0, up 40. Why do I know that's 40? Because I'm reading the outputs in the graph. And really quick, you can identify that function. All right. Here's what the activity is going to look like. For each problem, there's 10 of them. You're going to be given a table. You have to drag and drop the correct graph and equation into the blanks. So here are the 10 options, and then here are the choices. You've got 10 graphs, and you've got 10 equations. Drag them and drop them and match them all together. You can retake this activity up to 20 times. Good luck. Enjoy.